Right, so everyone has a beer, everyone has a hot dog. It was a nice session from Gerald. Next up we've got Dibran Mulder, who's going to tell us all about Blazor, which is a very interesting topic. Please take it away.
All right, thank you. I will also do it in English since there are some viewers joining us via YouTube Live. So make sure you all subscribe to that channel. I hear the guys like it if they hit more subscribers. Well, a little bit about me. I'm Dibran Mulder, a solution architect working for GSA Experts based in Utrecht. My Twitter handle just restarted my Twitter live, so I quit Facebook and went to Twitter. Fun fact, if you want to talk to Microsoft people, go on Twitter. Everyone is there. They're all hugging for followers. So if you have questions, you can ask them directly to the ASP.NET team, like Dan Roth, David Fowler, and stuff like that. Just a quick check on the audience. How much of you guys are .NET developers? Like almost. How much of you are JavaScript developers? So like half is backend focused. The other guys, I presume, are full stack developers. So yeah, we're going to talk about Blazor and WebAssembly, and then we also talk about JavaScript, since WebAssembly is not going to take away JavaScript. So sorry to hear about that. Yeah, don't start crying. Yeah, just some JavaScript code on the screen. This is why we all hate JavaScript. It's because it's not typed. It's because it's so darn unpredictable while it's supposed to be a human written language, while it's supposed to be easy to write, easy to remember, easy to predict what it's going to do. So like all these examples, if you add a string to an integer, then it will just concatenate the toString variant from the integer to the string. If you do an undefined equals to a test, then you get undefined test. Who wants that? Huh? Who wants that? Like a SQL, if you and null with a value, then you still get null. In JavaScript, it's concatenated. Why? Nobody wants that. Same goes for none. It's quite unpredictable. Yeah, because of this features, JavaScript is quite complex and it's quite slow at performance level. So if you look at the semantics for the plus operator, JavaScript engines need to do a whole lot of goodness to execute your code. It doesn't know from analyzing your code perspective if you're adding an integer to a string, or if you're trying to add an object to whatever. So it needs to do all kinds of runtime checks. Hey, what am I dealing with? Is this, what kind of variable is this? And because of this, yeah, JavaScript is an inefficient language. And yeah, well, that's what's making the web slow. But maybe even more important, that's what's sucking up your battery in your mobile phone. Since all these checks, all those runtime analysis of your JavaScript code, yeah, it just takes up CPU cycles, and CPU cycles equals battery usage. So a committee was formed by all major browsers like Chrome, Edge, Safari, Firefox, and they came up with a new spec, and it's the WebAssembly spec. And well, just to give you some sort of insight in what a JavaScript engine does. So if a JavaScript source code is downloaded from your web server, then it needs to be parsed. It needs to be a lexical parsing, just like your C# compiler does. It needs to build up a syntax tree. It needs to get that into memory. Then it needs to optimize that tree, and then it can actually execute into the browser. And what a lot of JavaScript engines do, like the V8 engine of Chrome, they try crazy hard to optimize it. So in the V8 engine, they call it the turbofan, and the turbofan is a piece of software that analyzes the code which is actually running into your browser, and then it determines hot paths, and it does all kinds of analysis and lowering to make code paths shorter, and because of that, faster. So if you ever wonder why, if you look at your Chrome tab and why is it taking up so much memory, so much CPU, it's not because of your website, probably. No, it's because it's running the turbofan at max speed. And it's trying to optimize it. It's trying to run your website faster. And this is becoming a major problem. Probably a lot of you guys have dozens of Chrome tabs open or Edge or whatever, and you're looking at why it's hogging all my memory, why I don't want it, and they don't want it either. But if they don't if they don't are the fastest browser, then people will just switch over to the other browser, which actually makes it, a self and strengthening effect. So people decided, well, let's quit with that stuff, and let's come up with a new spec. Let's create WebAssembly. And WebAssembly, nobody writes assembly. Yeah, the people in the 60s did. I guess no one is that old that he wrote assembly. Who actually wrote one piece of assembly? Yeah. And what did you wrote it for? Yeah. Speak to me. Okay. And how about you? So way back in the day, 80s, 68, programming, but well, nobody wrote a decent production system probably on assembly. Yeah, we all know Roller Coaster Tycoon is built on assembly. Whoever did that was freaking insane, super smart. So just to keep in mind, WebAssembly is not a programming language which you are going to use in the web. It's a compiler target, and by saying a compiler target, I mean there are higher level languages which compile back to WebAssembly. So if you look at webassembly.org, where the spec is defined, then they always will say, well, it's a target for instance C or C++. And it's important to keep in mind that WebAssembly is a target for languages without a runtime, without a virtual machine. So if you look at .NET, .NET contains a garbage collector just like Java. WebAssembly doesn't have anything for that. It's just a very low level virtual stack-based virtual machine. So there's no garbage collector in it. There are not even threads in it. Right now, it's just one single thread. You get a box of memory, go ahead, call some operations on it, that's it. And then you can use higher level languages like C or C++ to compile back to WebAssembly and actually run it into the browser. And that will result in a major shift right, if you look at this perspective, to a WASM binary. WASM is the abbreviation of WebAssembly. So it will hook directly into the backend of your browser. And to make it even clearer, it uses the exact same optimized code backend as your lower JavaScript already did. So for browsers, it was actually quite easy to implement the WebAssembly spec 1.0. So as of now, you can just load in a WebAssembly binary, load it into your browser, and it won't have to do all the lexical parsing. it won't have to optimize your code since it's already optimized for since it's WebAssembly, so the compiler already did optimization. And then it will be loaded directly into your backend, giving it huge performance. So these are the higher level goals, which I just copied from the WebAssembly spec. So yeah, it's all about making a portable, size and load time efficient binary format. And if you look at the load time efficient format, and we think about the previous slide, then it's quite clear that it's way faster load time. And also, if you look at the end of the sentence, it should include mobile and IoT. And if code is performing better, then it's cheaper to run, less battery usage. So it's matched that goal exactly. And then in the minimal viable product, which is the 1.0 spec, yeah, it's primarily aimed at C and C++, but other features are going to be developed, just like zero cost exceptions and threads and stuff like that. It's not in right now. Yeah, it's also designed to integrate into the existing web platform. So if people are going to say WebAssembly is going to take away all our JavaScript problems, then that's simply not true. They're going to live side by side, and WebAssembly is built for way other scenarios than JavaScript, and I will come back to those scenarios. Yeah, and lastly, they want to build a great platform. Yeah, everyone wants to do that. So yeah, some questions might pop up into your head right now. Is this going to replace JavaScript? Yeah, hell no. It's going to be complementary. Is this like one of the Silverlight plugins or Java plugins or whatever? No, this is already built into your browser, so you don't have to install, users don't have to install anything. It's built into all major browsers, including mobile browsers. So every browser out there supports the 1.0 spec. I got a question, yep.
Is it sandbox like a plugin?
Yeah, well, from a security perspective, the whole WebAssembly runtime is sandboxed into a predefined allocated memory space. So I can reference to, for instance, the Google I/O talk from 2017. Go look it back, and then they state that it's way safer than actually running JavaScript, since the pipeline, the engine, has to do all kinds of weird stuff, which can contain bugs, which may result into larger attack vectors and stuff like that. So WebAssembly, they claim to be very much safer than the JavaScript. So where did I leave? Yeah. So yeah, what are the key benefits? Yeah, secure, and also current benchmarks state that it's like 1.2 times native speed. So you lack like 20% of native speed. So if you compile a C program and you run it, and you compare it to a compiled C program to WebAssembly, then you will get 20% performance loss in WebAssembly. So that's pretty neat. It's pretty fast, and yeah, it's growing to be better. So yeah, just keep a look at the benchmarks. Right now I want to show you a quick demo of some applications built into WebAssembly. And let me switch to Edge. And what I did here, I will just load it again. We got a flower here. And what this guy did, I don't know if you all know the OpenCV C++ libraries. So it's an open computer vision library written in C#, written in C++, and then they compiled it to WebAssembly. And they also did the same to, they also tried to implement the same logic in JavaScript. And as you can see here, this is the JavaScript one, and this is the WebAssembly one. And I don't know why the comparator isn't really working, but let's pick a super edge, for example, and look at it. It's like almost 3-4 times faster than JavaScript. So bear in mind this is just a demo app, but it's open source. Go look at it, it's pretty neat. You can also switch to your webcam and do all kinds of analysis, video analysis on you. And these are the scenarios where WebAssembly is actually super great for. So highly mathematical components. Not really so much DOM or something else. So not much user interaction, more encryption, mathematical, stuff like that. So I will share the links with you later, but this is just an open source project. Go look it up. What's actually pretty funny is that older browsers older browsers like Internet Explorer don't support the WebAssembly spec. So what they actually did is they create an asm.js library. It's a JavaScript library which runs WebAssembly. So that's like a backup. So if you have maybe 2% of your customers still running on Internet Explorer or something like that, that's not gonna hold you back to use it. Yeah, as you can imagine, it's way slower if you run it on asm.js, but it's just for compatibility reasons. I don't know why this is some weird failed animation, but you can get a picture. So what is Blazor? A Blazor is a single-page web app framework built on .NET that runs in the browser using WebAssembly, and Blazor is a single-page web application framework. So it's supposed to be a competitor of Angular or React or other frameworks. It's not a way to just run .NET in the browser. It's really built for single-page web application development. And how do they do that? How do they run .NET in a browser? And that's pretty complex to actually explain. I will try short. So they grab Mono, and since I showed it earlier that WebAssembly uses an LLVM backend compiler infrastructure, and Mono happens to be compiled on LLVM for Xamarin. So they leverage that same technique to actually compile Mono to WebAssembly. As you might know, in iOS, everything has to be compiled ahead of time, and that's also the case in WebAssembly. So they just can't come up with a JIT or something like that. This is going to be pretty technical, but bottom line, they took Mono, they compiled it using LLVM to WebAssembly. So Mono actually runs into your browser to get Blazor up and running. And as I demo this later, this will become more clear. So where did the name Blazor come from? So Blazor is basically browser plus Razor. So Razor is going to run into your browser. So who did ASP.NET MVC? Yeah, almost 70%. So in ASP.NET MVC, Razor was used to create HTML and weave logic into your HTML. But all those HTML was rendered on the server. So the server used your models, created some bunch of HTML, sent it to the client, and then the client just displayed it. As of now, we're trying to get that Razor logic running into your browser. That's the whole point of Blazor. It's also a swanky jacket, a Blazor, worn by hipsters. This is actually from Blazor.net. So how does that work? In a helicopter view, you got your code behind files, just like in Razor. You got your templates, just like in Blazor. Those two are compiled into a .NET assembly, and let's say it's app.del. And with that app.del, a mono.wasm is delivered together with some .NET libraries. Those are all sent into files to your browser, and then your browser will just initiate mono.wasm, and those DLLs will get loaded into your mono.wasm, and then you got a .NET runtime in your browser, and it's pretty cool. I will just show you the Chrome DevTools, how that works. I'll just fire one of my demo apps, and let's make a little quiz. How much of you guys think the whole .NET libraries are like more than 5 megs, more than 5 megabytes? How much think like 1 to 5 megs? 1, 2, 3. How much do you think like 100 kilobytes? No, more? Okay, I'll just show you. So if I record the network in Chrome and just hit a refresh, then a loading page is shown until Blazor is actually loaded. And then look, it's 9 kilobytes. That's I'll just, yeah, it's 9 kilobytes. And this is actually experimental. So this is not even production ready. They can strip it even smaller. Maybe.
Control F5 maybe.
Let's see. Maybe I was lying. These are images probably 14. No. This is just one, but still. But still, look at the mono.wasm. This is just the precompiled mono. It's still 50Ks. They're going to get smaller. And then mono.js, which actually contains a whole lot of JavaScript files to interrupt with the browser. And then just DLLs get sent to the browser and they get loaded into WASM. It's pretty cool. And if you open up a DLL, then one funny fact occurs. This program cannot be run into DOS mode. So do not try to run it into DOS mode. And you can make up anything of it because it's bytecode, it's assembly. You shouldn't be able to read this as a human. So that makes sense. And then system and MS Core Lib, just the usual stuff to run .NET, just get loaded. And it's pretty cool. Well, let's continue with some slides, and then I will give you more demos of how Blazor actually is programmed. Because Blazor is a single-page application web framework, it needs to have components. Let me grab more water. Since every major SPA does components. Components are the way to program your client-side application. And on the right side, you see a typical component. It contains your HTML. It's mixed with Razor to hook it up with your logic, to hook up events, to get data in there, data binding. So components in Blazor right now contain these features. So data binding, lifecycle events, so after rendering, before loading, that stuff. State, so you can actually create properties into your code which contain the state of the application. Parameters, so yeah, you can give data back to lesser nested components. You can interrupt with JavaScript from within your C# code. So that's pretty cool. So if you want to do, for instance, call a library which does all kind of UI effects, then you can call that library from within your C# code. It does routing, so you can give routings for certain components. Like, let's say there's a search component, then /search will give you that component. Yeah, you got Razor syntax, and you got a whole bunch of classes, so you can also separate your logic and your HTML, make it 2 files, just like in Razor. Next to that, you got layouts. So this is exactly the same as in Razor. Then you can say, hey, this template uses this layout. That same logic is there, and you can also nest them. So you can have a main layout, and then for your search, you want to have this layout, and then all subcomponents will use that nested layout. It's also centralized into a folder. I will show you later. Lastly, it contains dependency injection. So, because it's .NET, you want to use all the libraries from NuGet. And bear in mind, the WASM, the Mono runtime, it's compatible with .NET Standard 2.0. So, if your library is compliant to that, then it can actually run into the browser. So it's pretty cool. Yeah, so on the top page, it looks like ASP.NET Core dependency injection. It's the same APIs. So you guys are probably familiar with that. It's the singleton, transient, and scoped dependency.NET types. Yeah, if you want to inject it into your Blazor template, then you just do add inject, and then it will find the iData access data repository here, and then you can just in your functions do actually we leverage a lifecycle event, so an override on a lifecycle event on init. So if this template is initiated, then we want to get the data repository, get our customers, and those customers will be stored in a field, which is the state of the component, and those customers can be shown in an unordered list. That's how it works. It's pretty, it speaks for itself. And at the upper page, you see page/customer list. That's the routing. So it's all there. And if it's all there, then we want to see it. As of WebAssembly, Blazor is experimental, so it's not production ready. I just leveraged some demos from the ASP.NET Core team. Those are all publicly available, so go check it out. I ran it, so this is Flight Finder app. So if I do here AMS Amsterdam to Seattle and I want to search it and I want to add a couple of them to my cart, it's just a basic app. But it contains some cool features. So let's look. We got is it visible for everyone? Yeah? So I got a shared which contains my models, my view models. I got a server and I got a client. And this example is built so that if you run the server, it will also hook up the client. So if we go to the startup page, I'll just close this here. Then you will see, hey, app, use Blazor and use my client program as my startup, as my static void main. Yeah. And then here are some compression types. So you can compress WASM. Let's see. If I go to my my client, then this is just the kickoff. It uses a browser renderer, and it uses a main CS HTML to actually load it. And if you look to the main, then, well, I get an app state injected, and this is my first component. I wrote a search component, and a search component with a parameter, a state.search. So the search, which is in here, gets injected into this component. And it also contains a lifecycle method. If I here, I'm in debugging mode, so if I go override, look at all those should render, on after render, those are the lifecycle methods, just like in Angular, you also got those. So let's switch to a component in here. Let's say it was the search, I guess, or am I right? Yeah. So we got a onSearch function, which is a parameter. So if I go to the main and I look, the onSearch is the state.search, which is a parameter of search. Then it's a function which gets injected as a parameter, and this function I can hook up to an onClick event, and then the onClick event will fire this function. And it's got default search criteria. Yeah, question?
Are the components the same as tag helpers?
Well,
because I see it's purple. That's right.
yeah. Tag helpers. Well, I think it's a little bit more complicated since you have nested components. I don't know if you have nested tag helpers. You can take the comparison better to real components in JavaScript frameworks. They work more or less the same. It's only written in .NET. So, yeah, well, if that answers your question. Look at the binding. So you can just bind a certain state to certain HTML controls and format them in values. This is all features of the Blazor framework. So let me hook up another example, which is probably better. This is another example. I'll just show it to you. This is actually the component sample from the Blazor.net documentation page. So since it's loading, if you go to Blazor.net, here, Blazor is an experimental. Don't use in production systems, since debugging is not supported yet. So don't try to convince your boss to use this in production environments. This is an example where you have a routing. Look at my routing here. A different route with another page. Parent-child components, nested components, route parameters. I will just show it. So if you want to do a route, then yeah, this page contains 2 routings. It's pretty simple. So well, basically I've almost shown you all the features. This is a view imports. So if you use a view imports file in a directory, then you can specify a layout, and then all succeeding templates will inherit that layout. And this layout is the main layout, and that should inherit the Blazor component layout. And then you get a add body attribute where the subcomponent is rendered in. So every component is rendered into this body allocation. It's almost the same again with Angular. So yeah, those are the features of Blazor. As I mentioned before, it's sadly not debuggable yet, but they're working on it. So yeah, bear in mind if you want to use NuGet packages, use .NET Standard 2.0. If you want to host and deploy this, I might be able to show that later. You can host it on ASP.NET Core, or you can compile it to static files and then use any web server you want. So just as if you host an Angular website. Those are all static files. Those are just JSON, JavaScript files or HTML files or CSS files. And then you don't need any smart web application server like ASP.NET Core to host your application on. Then you can just host it on file storage if you want to. So the SDK, .NET Core SDK contains a publish flag to actually compile it to static files, so that you just grab the files, save them somewhere on a web server, load the index.html, and then it will run. The roadmap. So a lot of goals are already met. So they got components, they got routing, they got layouts, they got more or less form validation. It's a little bit basic. They got dependency injection. They got JavaScript interrupt. They don't have live reloading during development, and that will probably come together with debugging. And yeah, the ability to run on older browsers via asm.js, that's included. It's not included into the tooling yet. So if you want to do that right now, then you have to do a whole lot of magic to actually load it, and then use browser detection to see if you have WebAssembly supported, and then load directly or via asm.js. Question?
If you're loading it on all browser, you're loading asm.js,
Mm-hmm.
looking at the DLLs.
Yeah. Yeah, so it's just like a polyfill. So asm.js will function as a WebAssembly runtime, and it will load in the DLLs. And then, I should say it will load in mono.wasm, and then mono.wasm will load in the DLLs.
So if you're developing a mono application on Chrome, does it also load the mono application for that?
It loads the mono runtime.
Yeah.
Yeah. Yeah, so mono is not built into the browser or anything. It's just the WebAssembly spec is just sitting there. It's waiting for WASM files. We happen to load in whole mono precompiled as a WASM file, and then on top of that, all kinds of DLLs will be interpreted and will be run. And then mono.wasm also contains garbage collect stuff like that. Yeah? Any other questions? Far? Because we're at the questions page. Yeah, thanks for. You got another question?
Yeah, one question. Do you know something about performance for the WebAssembly? You said it's 1.2 of the native performance.
Mm-hmm.
Below in the mono.NET framework for Blazor. Do you know what the performance penalties in?
I don't have quantifiable numbers. If you want to look at that, I thought Blazor.net stated something about that. So let's go to here and then docs, and then I guess this is one of the frequent asked questions. So yeah, this is like the question: is it huge? And I should have known that it's not 8 kilobytes. It's like in an experiment they met 60 kilobytes. But as always, if Microsoft has a experiment, then they try to rewrite it in a better way. So the ASP.NET Core team is actually rewriting the previous experiment, and that's why they don't met the 60K right now. But hopefully they come there. And just like I showed actually in my own example, caching will help a lot. And then interpretation is still way faster than JavaScript. So I don't know what the numbers are for Angular side to Bootstrap and get up, but guess it's comparable, and hopefully this will be faster in the future.
Yeah, I'm sure we will pay some penalty for the .NET that can all come the WebAssembly.
Yeah, but I also talked to David Fowler on Build, and he was talking about just like in .NET Core that you can wrap it all together in one assembly. It will probably also come to Blazor. So you don't have to get a penalty like max 5 downloads of files at the same time, and then those will be combined into. Yep.
But will that also be the same as I think it's called tree shaping, something where you essentially it recompiles the assembly that with the things you only use and the rest.
Yeah. Yeah, so that's the exact same functionality that Xamarin is actually leveraging. So if you have all kinds of libraries included into your project, then the compiler will try to shake as hard on the tree as possible that all things which are not used will fall out, and then only the parts of the DLLs that you actually use will be part of the actually package. But that's something which is generally built into Mono, I guess. So it's used, but I don't know the status of that. Any other questions?
Sorry, I've got a question.
No worry.
Some of the features, maybe go back to your example.
Yeah.
Where there's a razor file.
What? Yep.
Typical one. See, there's ads, and then if you go to one that has a binding that binds to data.
Oh yeah. This is another example, but I guess. Wait. Hold on. I will find it. Not this one. Here. This is a bind.
Yes.
Mm-hmm.
So why is there no at in front of that binding, but some other places there it's at, or is it just like? Like there.
Yeah. So I think the language service inside the Blazor Visual Studio stuff recognizes that bind is not a typical HTML attribute, and then it's not necessary to use an at. That's my assumption. The same goes for the format value, which is a formatting specific to Blazor. So, not sure.
So when you go bind equals, you're actually in C# land, and when you go there,
Yeah.
option equals, it's actually in HTML land, and if you go at, you're in C#
Yeah.
land again, right?
Yeah, exactly. So that's are some language tweaks, I guess. But if you want to be sure to be in, so this will probably work also. Yeah. So if you want to make sure you're in C# land, then make sure you're using that. Yep. So just to clarify one more time, this is your HTML, and then in the add functions, you're in your code behind part of your template, and then you can use your injected repositories, stuff like that.
Can there be a separate code behind file?
Yeah, that's actually also in one of the demos. So let's see here the base. So the Blazor rocks, and the Blazor inherits from Blazor rock base, and then you can just use a separate code behind file. And then if I quit it, then you also override the lifecycle event. So you can separate your logic from your view. So it's already pretty sophisticated for an experiment. Yeah. Any other questions? Or things you want to see, things I should explain better?
The DLLs that came with the application, the extra DLLs that you add, do you need to register them or have a manifest file?
Nope, it's just part of your project from your dependencies. So that's how they get loaded.
They get linked in by the compiler.
Yeah.
But at the moment it links everything, right? It links everything that's...
Yeah, look. Router.WebAssembly, and if I go, this page should also contain it, probably. Elements, head. Nope. Let me wait. Where is it? Was it this one? Nope. Yeah, I was looking, or it was like if you were loading the page, then it was probably. So if it. Well, at some time you could see a script tag, and then it will say which DLLs it needs. And from a Blazor perspective, that's because of this tag, which references your assemblies, which get actually loaded as static files then. Maybe if I do this, hold on. Just one experiment live on stage. Oh, this is actually not using ASP.NET Core, but just static void main ring. Locals. Yeah, look at this. Woohoo! I found it. So the main is Blazor.d and the entry point, and then the references, and those get downloaded then. Funny. Huh? Hey, and the linker is enabled. Yeah, so this is the bootstrapper, which you see waiting for Blazor to load, and then Blazor.js probably use, module is the call to actually load in WebAssembly files. I wouldn't be surprised if somewhere here was mono.wasm, but can't really find it right now. There's one more. There's a lot of JavaScript here. This is all precompiled. You don't have to worry about this. So anything I used is not secret, or you can just make a photo of a couple of these, and then go look it up yourself. Any other questions? Things I need to clarify in the back?
Are there any real additional practical limitations imposed on your code in the runtime, like the limit on the amount of memory that you can use, or certain bits of the framework that you can't really use?
I don't know if there is a max on WebAssembly memory. So I don't know that. Second, there are some features in .NET abstracted away. So if you do multi-threading, for instance, it's just going to work on one thread. So it's going to fake it. So bear in mind that. So if you can program async await, whatever, but it's not going to await anything. So just because WebAssembly is just one thread only. So there are some tricks in place which you don't see, but you should take them into account.
You probably can't access things like the file system of the browser, right?
Nope.
I mean,
No.
maybe a bit of a problem.
Yeah, that's true. I don't think that's even part of .NET Standard 2.0. File systems are platform specific.
Right.
If I'm right. Okay. Yeah, any others? Nope. Then that's it. Thanks for your attention.
Thank you all for coming. Also from Dutch.net side, I want to thank .control for hosting us at this event. Thank you very much. Modox was awesome.
Yeah, true.
It's not a good lead because they arranged it. We also have a small present for our dear speakers.
Thanks.
Thank you so much for your great talk.
Yeah.
I'm
you're
not a real
very-
techie, but I even enjoyed it.
Thanks. All right.
I think you understand it.
Okay.
Or comprehend it. Thank you very much, and well, thank you all for coming. There's still some beers or cokes or whatever you want, and I thought it was a success. So, thank you all.
Yeah. Thanks. See you.